Artificial intelligence appears to have an endless appetite. Every new model is trained on more books, websites, conversations, images, videos, and code than the generation before it. The formula has seemed simple. Give the machine more data and computing power, and it becomes more capable. But the internet is not infinite. Humanity has produced an enormous amount of information, yet only part of it is useful for training advanced AI. Much of the web is duplicated, unreliable, private, protected by copyright, poorly written, or already generated by machines. The supply of high-quality human material is much smaller than the internet itself. AI companies may soon have enough computing power to build larger models, but not enough fresh human knowledge to teach them. The machines are becoming hungrier as their best food becomes harder to find. So what happens when AI runs out of human data? Why AI needs so much of us? Modern AI begins with examples. A language model studies patterns across vast collections of text. It sees how words connect, how explanations are structured, how stories unfold, how code is written, and how people respond to questions. The system needs variety because intelligence is not built from repeated copies of the same idea. It needs science, history, humor, disagreement, corrections, and expert reasoning. As models grow, their demand for training material also grows. Developers do not only want more words, they want better ones, accurate research, carefully written explanations, useful code, specialist knowledge, and examples of difficult reasoning. High-quality data is expensive and limited. Humanity creates new information every day, but not at the speed AI laboratories can consume it. A person may spend years becoming an expert and weeks writing one paper. A model can process that paper in seconds. AI can read faster than humanity can create. The internet has already been read. The early growth of large language models was powered by the open internet. Websites, books, discussions, news archives, reference pages, and code repositories. But once the most useful parts have been collected and used, scraping the internet again does not create new knowledge. Training repeatedly on the same material can still help, but repetition eventually brings weaker returns. There is also the problem of access. Publishers, artists, writers, programmers, and website owners increasingly question whether their work should be used to train commercial AI without permission or payment. Some platforms restrict automated collection, negotiate licensing deals, or keep valuable content private. The phrase "running out of data" does not mean every word online has disappeared. It means the supply of fresh, diverse, high-quality, legally usable human data may no longer grow fast enough to support the old strategy of making models better by feeding them ever larger portions of the web. AI begins eating its own output. As AI-generated content spreads online, future models may encounter text, images, and videos created by older models. At first, that may seem harmless. If an AI can write a clear article or create a realistic image, why not use that output as training material? The problem is that synthetic data can contain hidden weaknesses. It may repeat common patterns, remove rare details, amplify errors, or produce information that sounds convincing without being true. Imagine making a photocopy of a photocopy. The first copy may look almost perfect, but if each new copy comes from the previous one, small distortions accumulate and fine details disappear. Something similar can happen when models train carelessly on generations of machine-made content. The system may become increasingly confident in a narrower version of reality. Rare examples can vanish, biases can strengthen, mistakes can return as training material and appear more legitimate the next time. Synthetic data is not automatically bad, but it must be checked, filtered, and connected to reliable sources. Otherwise, AI risks learning from an internet filled with echoes of itself. The synthetic data escape plan. One solution is to let AI create new training data. A model can generate millions of questions, code examples, simulated conversations, and problem-solving attempts without waiting for humans. In areas where answers can be verified, this can work well. A model can attempt a mathematics problem, check whether the result is correct, keep the successful solutions, and learn from them. It can write computer programs, run tests, and discard the code that fails. Synthetic data also allows researchers to create rare situations on purpose. A self-driving system does not need to wait for unusual road emergencies to happen naturally. Simulations can create difficult weather, sudden obstacles, and dangerous traffic patterns repeatedly. But synthetic data has a major limitation. The teacher must know how to judge the answer. Mathematics and code often have clear tests. Human values, medicine, politics, creativity, and social behavior are much harder to score automatically. If the model generates the lesson and also grades it, errors may survive. Synthetic data becomes powerful only when there is a dependable way to separate useful discoveries from polished nonsense. Humanity becomes the premium data set. If ordinary internet data becomes exhausted, the value of real human knowledge may rise dramatically. AI companies may compete for private archives, scientific databases, workplace documents, video libraries, and expert demonstrations. The most valuable data may no longer be random public text. It may be information created by people who know something rare and can show how they think. A surgeon explaining a difficult decision, an engineer diagnosing a machine, a lawyer examining an unusual case, or a teacher correcting a student may provide more value than thousands of generic web pages. This could create an economy around human experience. Experts may be paid to produce training examples. Companies may treat internal data as a strategic asset. Creators may license their voices, styles, archives, and knowledge to AI developers. But it also raises serious questions. Who owns the information created during a person's work? Will workers be paid for teaching systems that may later automate parts of their jobs? When human data becomes scarce, human life itself may become something companies compete to capture. AI may have to learn from reality. Running out of text could force AI beyond the internet and into the physical world. Humans do not learn only by reading. We touch objects, observe consequences, test ideas, move through environments, and discover facts through experience. A child understands gravity because objects fall, not because every explanation came from a book. Future AI systems may learn more through robots, sensors, laboratories, games, simulations, and direct experiments. Instead of only studying what humans have written, machines could gather new evidence from the world itself. AI could run experiments, study materials, observe ecosystems, or control robots that practice physical tasks, producing information that did not previously exist online. This could change AI from a system that imitates recorded human knowledge into one that actively creates new knowledge. But it would also be more dangerous. A model exploring a simulation cannot damage the real world. A model controlling machines, laboratories, or infrastructure can. The data shortage may push AI toward greater independence, while humanity is still learning how to control it. AI is not about to consume the final sentence written by a human. New books, discoveries, conversations, images, and videos will continue to appear. The real problem is that demand for high-quality training data is growing much faster than humanity can produce fresh, reliable material. The old formula of scraping more of the internet cannot continue forever. Developers will have to use data more efficiently, pay for better sources, generate carefully verified synthetic examples, and allow machines to learn through simulations and real-world experience. That could slow AI progress, or it could force the next major breakthrough. A shortage of human data may lead to systems that teach themselves, run experiments, and create knowledge beyond what they were originally given. But there is a deeper warning inside this problem. AI was built from humanity's words, art, research, arguments, and mistakes. If human-created information becomes buried beneath endless machine-generated content, future models may inherit a weaker picture of us. The next stage of artificial intelligence will depend not only on how much data exists, but on whether that data still carries something genuinely human: originality, experience, judgment, and truth.